Hello, and welcome to Enhanced Information Solutions webinar on data integrity with our partner, APERIO. I'm Jack Audie, EIS's Director of Sales and your host for this webinar. This webinar is being recorded and will be made available to all registrants. Here's the agenda for today. First, we'll have a poll followed by an introduction of EIS and today's speakers. Today's speakers, John Peterson. John, could you introduce yourself, please?
Yep, John Peterson here. I sit the product direction here at APERIO. Prior to APERIO, I spent a long time at OSIsoft. So I was on the PI server team and VP of engineering at OSIsoft, where I got involved with this this operational data. Following OSIsoft, I was a co-founder of Seek, where we set out to build tools to make use of all this great data that you get in your PI system. And I'll talk more about APERIO in a little bit when I do an introduction on that.
Okay. Thanks, John. Katie, could you introduce yourself, please?
Yes, hi everyone. I'm Katie Gates. I'm a customer success manager here at APERIO. So I work with our customers to ensure their objectives are met with our software. Prior to joining APERIO, I spent some time at Seek with John, led the customer success management team there, and recognized the importance of data quality in getting quality insights from your data. Prior to that, I was in power generation operations in the US Navy, nuclear power, and I have a degree in chemical engineering. So that's my background.
All right. Thank you, Katie. Bryce, please introduce yourself.
Hello, everyone. Bryce Lawrence. I lead our operational intelligence team here at EIS. My background came starting more on the automation side, PLCs, DCS systems, then moved into working on PI systems and other process data historians, and now fully entrenched in working with our customers on their digital transformation.
Okay. Thank you. So before we get started, I want to describe a little bit of who is Enhanced Information Solutions. Well, we were founded 30 years ago in Stillwater, Minnesota. We do a great deal of MES consulting services, PI services, Seek services, IOTA, OT cybersecurity. And we have three primary products: eDataSheet for manually entering data into a PI or Canary system. We have eForms, which is an electronic logbook with workbook and a complete audit trail. Okay. And we also have a PI event frame manager, which allows you to create and edit PI event frames without having to give away the PI system management tools. EIS locations and projects. You can see we are a global company. We are located all over the world. Most of us work out of our home offices. Okay. I've shared this story before, but I wanted to do a quick introduction with John. When John was Vice President of Engineering at OSIsoft, he had a very good comment to one of our to a young developer on one of the interfaces, and his comment was, the purpose of a PI interface is to reduce the entropy, not just relocate it. Well, those are words to live by. APERIO seems like a natural extension of that journey. So with that said, John, could you please introduce APERIO and who and why is APERIO?
Yeah, great. Thanks, Jack. Yeah, that story Jack was talking about, if you're familiar with some of the PI interfaces, that was the OPC A and E, alarms and events interfaces. And we would concatenate a bunch of alarms and events together and put it into a string tag, only to leave it to other people to go yank them apart again somewhere else. So it kind of drove me crazy, but hey, that's the way things happen sometimes. So why don't you pop to the next slide? I'll tell a little bit about APERIO. I spent many years at OSIsoft. A lot of my time was working on the PI server, and the focus was reliability of that. And yeah, it's pretty reliable. A lot of people consider it, some of the more reliable operational technology out there. That just comes from a lot of hard work. And then that's where data quality starts with these solid systems. And then we built on that. You guys built on that with good networking, monitoring interfaces, monitoring process, IO rate tags, and other mechanisms. And that can bring the quality so high. And then we saw from the survey, there's some reasonable good confidence out there, which is great. When I first came across Apereo, it was very ingenious. What we're doing here is we're looking at the data itself and looking for data quality. And it's really the next step. And so I was fortunate enough to be able to join the company. And the approach, and what I'm talking about here is our product called DataWise. And the approach is leveraging ML and AI techniques to look at the data itself, the operational data, the squiggly line, sometimes I call it. And by looking at that, we can detect many different problems with it, really problems from the sensor all the way up to these cloud-based databases now. So we really go across that whole data value chain. We'll be talking mostly about the static analyzer, which is looking at metadata and also doing some of the archive analysis as well. So this product DataWise, which I'm showing the algorithms here, it's all unsupervised approach to this. Which is the only way you can do it when you got the scale. I think most of the people had, 100,000 or more tags, and that's not something that you can do by just looking at a bunch of trends. So with that, I'll hand it back to you, Jack.
Okay. All right. I'm going to hand this over to Bryce. Talk about the static analyzer. All right, Bryce.
Yep, sharing.
Okay. Yes, sir. You can share your desktop now.
Perfect. Okay, we'll jump in. So the static tag analyzer is designed to help you optimize the utilization of your PI historian. So these resources you're trying to utilize are PI licenses, your disk space, processing power, etc. So the first output we're going to take a look at is the analysis of the PI tags and their configuration. So this can be used for tuning your PI system. So if you're looking for tags that are no longer used, not updating, incorrectly configured, optimizing data collection and storage through compression exception. So the output of the tag analyzer is, in this case, a populated spreadsheet. And then you can take this and it can be customized, and then it can be used as a data source for SQL or Power BI. And then we're just going to use Excel in this example. In this case, we're actually going to be looking at tags that are analyzed over a 31-day period. And the period is completely customizable. The static analyzer is designed to be installed on your PI system on the data archive server, and then it can run for minutes, hours, days, depending on the size of your system and how far back you're going to look at data. As I said, the output can be a CSV, and then you can bring it in Excel, and then we will have extra other templates with other calculations that can be used in it as well. So we built these examples around the point source, but data can be sliced any way you desire. Examples might be the type of measurement by using the engineering units. You might do filtering based on the tag or the name or the description, etc. So this first tab gives us how fast new values are coming in by looking at the minimum number of seconds between archive values. There's multiple columns that are available to normalize this data, but in this example, we're just looking at the raw minimum time in seconds. So then you could potentially use this for determining what an optimal scan rate might be coming off your interfaces. The second one here is the quality of the snapshot value at the time the static analyzer was run. So this can be combined with the percent good, which is your percentage of good values over, based on the number of samples taken to help determine Again, if there's tags that have any issues, if there's tags no longer being used. So typically you would run the static analyzer a number of times, say over a 1 or 2 month period, maybe once a week, just to get a more accurate picture to make sure you didn't just pull something that happened to be bad that day. Building on this is this tab here showing the number of seconds since the value was updated. So this is based on the timestamp in the snapshot value, compared against the time that the static analyzer actually ran. So again, this can be an indication of tags with issues, right? So if you have ones that have been updated for days potentially, or tags that are just no longer valid. And again, you get the most value of this if you run it multiple times, so you can see a trend, not just a point snapshot. And then this chart here, we're looking at the minimum percentage of change. So this is percent of change based on the zero and span of the data between archive values. So what this tells you, along with the calculated sample period in seconds, which is based on your total samples over the period, in this case 31 days, gives you a good indication of values that may be overcompressed because they're not updating soon enough, or undercompressed and they're taking up too much disk space because they're updating far faster and saving more values than are actually required. So there's also a maximum data value change. So this value and the minimum value are used to calculate an observed span and zero for a PI tag. So this can be used for both tuning the PI point parameters and also for monitoring the data quality. The assumption being that values outside the observed range are potentially erroneous and may require action. So the second output we're going to look at is for referencing PI tags. This could come from Process Book, PI Vision, Data Link reports, or even Seek, which is what this example is showing. So this is particularly useful if you're converting Process Book displays over to PI Vision, or if you're making new additions and changes, and also for documentation of key parameters and calculations. It's also important to use this if you're tying back to actually removing dead tags from your PI system to verify where those tags might be used in displays and reports. Or maybe you might even be converting your data link spreadsheets over to reports or PI Vision displays, and you just want to know what calculations to take from these spreadsheets and put into AF. And along the lines of AF, this can also track a PI tag into an AF attribute, and then its use with it in an analysis, and then the resulting calculations are also included. So thus you're able to track a PI tag all the way through its AF elements and into displays and reports. So tag references for Process Book, Vision, Seek, Data Link, etc. will have raw data, and then you can slice them and dice them as desired. It might be by workbook, by tag, by display, by spreadsheet, etc. So in this case, we're actually looking at PI tag references and Seek workbooks. So this could potentially be used to help determine which tags need to have monitoring of their data quality based on the number of references for potentially KPIs being used. Okay, Jack, did we have any questions pop up?
Okay, I'll just add a little bit here. It's at the end of the day, it's about where are the PI tags being used, and then we use the word reference count. Just count how many times. It's hard to tell what tag is more important. Maybe if it's referenced more, it's more important, but that's for you to decide. But we can tell you where everything's being used. And the way this is implemented is we have these crawlers that you just point them at an application, if it's a web-based application like PyVision or Seek, there's an app server. We crawl that app server and just count the things up. If it's a file base like Excel or process book and things like that, just point it to a SharePoint, a file share, network file system, and we'll just crawl that and count things up. So it ends up just being a database of where are all your tags being used.
One of the things I've seen this used is you have multiple tags pointing to the same point source. Basically, you're duplicating the tag. And although you could get rid of that duplicate tag, the challenge is going to be maybe that tag is being used somewhere. So you can at least see if it's being used and you can plan accordingly before deleting it. So, okay. Let's do this.
There was one other question asking about the reference count, if it's able to see usage through Pi Web API or PyAF SDK.
Well, yeah, you really can't from those two things. So those are just APIs. So it's just the data is just transient through there. You'd have to do something like that. You would have to go instrument, those things, which is not that viable. Something like a web API could do that, right? We actually used to have a feature like that in the Pi system where you could go turn on a utility within Pi. It was pretty heavy load on it, but then while this thing was on, it was just counting, what tags are being accessed right now and how much data is being accessed too, by the way, and build up that database. So that's something that, it has to be done kind of either at that app server level or at the API level to do something like that. But once the data gets stored in a spreadsheet and in a web application like a Seek or PyVision, we can pop into those databases and count that up.
Great. Hi, everyone. Let me share my screen and I will demonstrate DataWise. All right. So as a Pi administrator, or really administrator of any time series data store that I may be using, I can monitor the quality of my data using APERIO DataWise, in particular, this portal overview, which displays a tree map organized by the configured hierarchy of my data. So from here, I can easily identify where there may be data quality issues either at the interface, the site, or the asset level, indicated by the data quality index, or DQI, which tells me the percentage of time my data is healthy. DQI is the KPI I track over time to maintain and improve my data quality. Anything below my 90% target DQI is highlighted in red, such as what we're seeing here for the Philadelphia site. So let's jump down a level in the hierarchy to see if there's a particular asset driving my site DQI down. In this case, it's pretty clear it's this secondary Philadelphia node at 35.6%. If I click on the title of this node, I can explore the underlying channels. So these are Philadelphia inlet riser sensors. From this channel timeline view, I can see the data quality events, or DQE, across all of these channels, color-coded by engine. The key is shown here on the right-hand side. So each DataWise engine detects a different type of data anomaly that point to where in your data architecture the issue may have originated. I can see here that there are extended out-of-range events across all three channels with intermittent bad values. And when I hover over this, I can see a little bit more information about those events, including the start and end time, the duration, the expected parameter that the model is monitoring for versus the actual. So the difference between this expected parameter, such as for this out of range, the expected range in which the value should fall, and the actual value factors into these severity scores that you can see on the left-hand side. And each data quality event, weighted by the severity score as well as its duration, detracts from my 100% data quality index. I see here that during this most recent out-of-range event, the source values, which I can see is in this expanded view, dropped to 0. So based on all of these indications, the likely cause is a communication error between the historian and the DCS or the controller for these sensors. Changes in gas inlet riser density could indicate gas in the riser and lead to an uncontrolled unloading in deep water, a severe environmental concern. So it's critical for us to have representative data from these sensors to prevent such an incident. I'll open a case to prompt our maintenance team to explore the connections here. Let's call this Philadelphia bad values. And when I add this case, I'll see it come up under my list of cases here. And it captures the channels we were looking at during the time period of which we were looking at them and the data quality events associated with each, so that I can send this to somebody else for root cause analysis and action. When my maintenance team comments here that the connection has been restored, I can close this case. Let's zoom back out and look at all of the channels at our Philadelphia site. Ooh, we can see that there are bad values throughout all of them, or across all of them, starting around September 24th. The error proportion here, though, is only about 6.5%, so I'm getting mostly good data in between these bad values that are detected, which is why my DQI for this channel is still 97.3. However, if these bad values become more frequent, it'll negatively impact my DQI. I want to know when that happens. So for all of these channels that have bad values but still have maintained a good DQI, I'll set up an alert, which will be triggered on DQI less than 90. I can send this to my Pi server of choice, indicate the web ID for the element that I'm using to capture these DataWise alerts, and let's name this Philadelphia DQI. I'll add a description here just to help me remember what this is for. Alert me when DQI for Philadelphia water pumps drop below 90%. I'll save that. You seeing Pi now? Jack, can you confirm that for me?
Yes.
Awesome. So then when the daily DQI for any one of those channels drops below 90%, it'll create a new event frame under my APERIO DataWise alerts element here. I see one here. So this will be a daily event for when the daily DQI drops below 90%. And it'll include extended properties such as the rule name and description that triggered this event frame creation, the channel name and ID that meet the criteria of the alert, and the daily DQI from that channel. And now that I have an event frame in Pi, I can configure Pi notifications to alert me to data quality events in near real time, or I can integrate with Maximo or another asset management system to resolve any sensor issues, or I can integrate with ServiceNow or another IT ticketing system to resolve any IT issues. DQI can also be written back to Pi or Canary as a tag for monitoring and reporting. APERIO integrates with your existing business processes to identify and mitigate data quality issues.
Okay, very good. Well, we have a few questions here. First off, let's start here. The tag reference you referred to, does it check? Now this is kind of goes back to the static tag analyzer. Does it check AF, Vision, and data link where the tag is being used?
Yeah, and the answer to that is yes. And conceptually, what we're going to do is essentially just create a driver, a crawler, and point it at any app. So as long as that application has got either an open file format like Excel does, Vision is pretty simple because all that data lives in SQL Server. So you just need read access to your PyVision SQL Server. We'll just walk through that periodically and count things up. So conceptually, it's pretty straightforward. and then get that and build up a database, and then run this thing periodically to maintain that database of where are your tags being used. Yep.
Okay. Okay, question. How do we handle planned downtime? So like a single-use bioreactor,
Yeah,
you're moving it.
yeah, that's a good question. We throw that at APERIO, we throw that into the category of algorithm or engine accuracy. And what we did in the beginning, well, see in our product right now, is you give us some control tags, and we'll look at those control tags. And if those control tags go to 0, we're going to, well, this thing's not running, so let's not run our algorithms with it. But detecting something getting shut down, I know it's harder than it seems like it should be, but our data scientists have worked out algorithms to automatically pick up shutdowns. And then by automatically pick up shutdowns, there's 2 advantages to it. One, don't use shutdown data to train your models. That's going to improve your accuracy. Don't run your models when the thing is shut down. That's going to improve your accuracy as well. So shutdown is just a state a piece of equipment could be in. It could be in other states as well, like making product A or product B or this grade, or maybe it's ambient conditions, or maybe it's a production rate or a power generation rate. And we're going to be taking this notion of different states. That's something we'll be adding to our product. Once again, all to improve accuracy of our models, or the algorithm. And by accuracy, we mean minimize the number of false positives, minimize the number of false negatives.
Okay. All right, thanks. Another question here. How much of these tools are on-prem and how much is cloud-based? And are any of these cloud services FedRAMP approved?
Yeah, so FedRAMP approved right now, no. We do have SOC 2, so we are moving along that compliance route. So the DataWise product that Katie just demonstrated, that is it's a software as a solution, so it's cloud-based. However, we can work with you if we need to install in your tenant in AWS or Azure, wherever you're running it, or on premise. We prefer to go the SaaS or the cloud route. What we're calling a static analyzer, and by the way, that's like an engineering name that I threw on it. We're gonna have a better name for that, but the more of the commercial name for it. So the static analyzer, we're gonna have 2 versions of that. First, we're gonna have an on-prem version of it. It's just gonna be a download of essentially an app, a signed application with a Windows installer. You install it and run it. We'll probably leverage a database, a small database on the PC, and then use Power BI or Excel to point at that little database to see things. But we are going to incorporate that into DataWise as well. So we will have a cloud version of that.
Okay, good. Are there scalability issues?
Yeah, I mean, you got to worry about scaling it. Anything you do, outside of some trivial apps that you might put together, and so we're well aware of how to make this stuff scale, and we're applying those principles to it. Pi does a great job of serving data up. I mean, I've personally worked on a lot of that scaling of Pi, and we're applying those same principles. We applied those same principles at the product we built at Seek, and we're doing the same thing at APERIO. But yeah, absolutely. And you saw the numbers. I mean, at least 10 years of data from vast majority of people, and at least 100,000 points as well. So if you're not thinking scale, you're not going to be very successful.
Okay, good. Thanks. All right. Is there any way to segregate out the tags based on a type, like, for example, block of tags, like environmental, production, DCS, machine learning?
Yeah. Yeah. Katie, I know you can chime in too if you want to answer that. So go ahead. Why don't you answer to explain this notion of scopes, Katie?
Yes, absolutely. So the notion of scopes is that you can group channels together to form an aggregate DQI. So that's the benefit of calculating that metric at the channel level, is that you can group and aggregate it as you choose. I showed you how that can be done based on the hierarchy of your data and the nodes you already have in place. But you can also do a custom group called a scope within DataWise based on query criteria or just hand selecting a number of different channels.
Okay.
Yeah, this data, by the way, it ends up being very BI-like data with, if you're familiar with that, this dimensions and facts, or an engineer would say independent variables and dependent variables. And we pull all the metadata over, we make all the metadata available as well, so you can use that as dimensions to slice things on, or you can just do an ad hoc grouping. So we have a good customer of ours with some environmental reporting, and they put all these important environmental reporting tags into this collection of channels. We use that word channels for tags, and that can be really any query that results in a set of tags, and then we can do all those DQI and data quality events and all that on that group of tags, so you can really focus in on things. And there's no limit to the number of these scopes or collections of tags that we support.
Okay. Here's one question here around is there data like use cases, any data like surrounding like the business impact of some of these bad quality?
Yeah. Probably a really good use case. I'll go back to that environmental. Good customer of ours. They have a mandate from at board level mandate to accurately report CO2, and it's in the context of producing hydrogen gas, and so they're using DataWise to monitor those tags. And it's a little bit after the fact, but they did notice once they start monitoring that they had some tags, from some of the sensors that weren't reading correctly, and they ended up over-reporting by 25% of what their CO2 emissions were. And we have another customer. It's in the line of methane leaks, or a gas production company, and they store methane in these tanks, and they're using APERIO to monitor the pressure sensors on these tanks to assure it's accurate, and so their methane emission reporting is accurate as well. So, and we have many more of these use cases out there.
Okay, good. And I saw there was kind of it has to do with these cases that you basically, who reviews these cases? I see that you can also push them into PI event frames. I mean, how is that typical? You have there's like a dashboard. I've also heard this kind of described as kind of like what the knock should have been. Okay. So who typically kind of reviews some of these cases? Are there PI admins? Are there people that they have work teams? Do they push? Can you push it directly to Maximo, like through event frames and that?
Yeah. Well, there's a couple things there. Is so generally the user of DataWise right now are what I kind of collectively call data owners. So they're the people that are responsible for supplying quality data to the business. And so we created this thing called a case in APERIO to allow one of these data owners to collect up some data quality events that need further review, need to be tracked a bit to go and address the data quality issues. That can get a little bit tricky in scaling and business processes and things like that. So most companies, well, I'll say everybody I talk to, they have some business processes in place for addressing a failing sensor or an IT problem that's causing a data quality problem. So right now, that's a little bit of a manual step, but we're starting the integration. That first piece of the integration is to push these data quality events or the DQI into event frames. And from there, we can go trigger, PI notifications get triggered. We have one customer that has that integrated into their maintenance, essentially their maintenance system, where it gets forked in one direction. Is it an IT problem? Get IT people working on it. Is it an OT problem, like a sensor problem? Get OT working on it. Those are generally two systems. So the case is becoming the integration point into your existing business processes when it comes to data quality, as I mentioned, which has two kind of broad OT, to a fork goes over to OT or over to IT.
Okay. Along that line, is there a way to notify directly rather than having to pipe everything back in through an event frame at PI? And I think this is also for Canary customers.
Yeah, that's always from a product perspective, that's always a tough question, right? To whip up in an application to have it push out an email is pretty trivial to do. However, if you really think what notification should be like, it'd be well, I got a mailing list, or I have a different channels to notify through, and then what do you do if you don't get acknowledgement of that thing? You should have an escalation list. You can go on and on. Our position right now is we would rather integrate with your existing system, and we don't care what that system is. If you're using ServiceNow or PagerDuty or Pi, we believe that's the best route. However, we're open for discussions on moving that kind of functionality into our product. You just pick up more responsibility than it looks like on the surface when you go do that. Happy to dig into that from a product perspective, though.
Okay. Well, here's another question about looking at under compression. We've got some customers right now that are shifting archives far too often, and they've come to us. And we addressed it, but can you describe how we look at, or how EIS or how static tag analyzer, how we look at the under compressed? Could you expound on that just a little bit? How do we check the exception compression?
So I know there's other tools out there, and I haven't rolled up my sleeves and looked at those tools. It's something I've been messing around in compression for many years. In a perfect world, you can't do this in practice, but if you could, this is what you would do. You would set exception specs to the precision of your sensors. All right. So anything smaller than the precision of your sensor is by definition noise. You would scan that infinitely fast in your PI interface. You would scan it infinitely fast because it's only going to report when there's changes. Then you're going to catch all the changes, right? You can't do that either, right? So that's how you would set up exceptions. And then compression, you would set to the precision of your process. And so if my process is sensitive to a 5-degree switch, maybe set it to compression to 2 degrees or a degree and a half or something like that. Okay, that's a perfect world. So what can you do statistically? You can just count samples and go, well, that seems like too many samples. Let me bump up, samples, your average sample rate over 24 hours. Let me bump up compression because I think that's too many, or I don't think it's enough. So I'll lower compression. The thing that we're statistically doing in the static analyzer is we're measuring sometimes this gets confusing talking about, but we're measuring the quanta of the change in value between subsequent readings or samples, right? If we take that delta value, that change in value, but we also calculate the observed zero and span, not the zero and span of the PI tag, the observed zero and span, then I normalize that value to percent, okay? So now I can look at all the data in your PI data archives, and I can look at a normalized in percent, per 100, what your delta values are. I can take the minimum of that. That minimum is kind of the quanta. That is your effective compression. If that minimum is, let's say, 1 part in 100, you're probably okay. If you started out life maybe 1 part in 4,000, if it's a 12-bit AD converter, it's still a lot of compression down. But if that thing is 1 part in 50, 2%, maybe it's overcompressed. So that's one of the tools that we're giving you in with the static analyzer. Once again, I'd love to talk more about it if you get other comments.
Okay.
So just look at that quanta, a normalized quanta that you're storing data at.
Okay, thanks. One other question here. How would we integrate to snow? I'm not familiar with snow.
Snowflake or snow?
I just heard snow. Martin, you want to type it in here?
ServiceNow.
Oh, yeah, ServiceNow.
Okay, I saw snow. Okay.
Yeah, ServiceNow. You should call them up. Maybe that's a nice little branding they can do. Snow. So ServiceNow, come talk to us. All we're doing is waiting for a customer to want that integration, and that's it. Our strategy is integrate to existing business processes, which means existing systems. We hear ServiceNow all the time, and then we hear SAP PM and IBM Maximo. So very interested in doing that.
Okay, great. So one of the things we have right now, we have a data quality trial. EIS and APERIO, we're offering this data quality trial. We'll basically analyze an archive for static tags, overcompressed, undercompressed, etc. We'll go through the analysis, and then we'll give you a report on that. And then we will also install DataWise in the connectors and create DQI dashboards for 30 days, 60 days if it makes more sense, right? And basically, it's just a simple trial to get over the initial activation energy of how do you go through a data quality initiative, okay? And this particular offering that we're doing is it's $5,000 grand total, $2,500 for EIS, $2,500 for APERIO. But the idea here is that it's a low cost way to get over that activation energy and start with and take a look at data quality. So, okay, now with that said, if you have any questions, please send me a note, jack@eisinc.com, or also, please take the survey at the end of the webinar. You'll be presented with a survey. Please take that, and a link to this webinar recording will be emailed to everybody that attended, everybody that actually registered. So there are some people that registered and did not attend. Okay. With that said, this concludes the webinar. Thank you very much for your time.